Hello, welcome to the channel. So we've got a Masco MA17N on the bench. This is a slightly smaller version of the MA25Ns that we've done previously. This only has 2 channels and the phono. Treble and bass, and this amp's in for a check over and possibly modding the phono to a master volume. We're not going to do a massive amount to this one, unless of course it's not clever inside and it's been worked on, all this, you know, bad workmanship, whatever, but we won't know that till we open it up. In fact, let's open the bottom up now. Right, we're looking inside and you can see we've got these Sangamo capacitors in here, which aren't rated, to be fair, from what I've seen on videos and things of these amps being restored, or amps with these capacitors in. They're in quite a lot of things in the States, vintage amps, but it's had quite a bit of work done to it, and it all seems to be okay, as long as these caps just seem a bit small, but if they're the correct rating, then we just need to check that. Fuse holder's loose, no big deal. We've got, looks like a bypass capacitor there mounted. That's not a very good way to do that, getting all the heat from the tube, but it'll probably be okay. That looks new, but most of it's pretty much original. Obviously it's been recapped, the electrolytics have been changed, just like we've had a cap there of 0.1. Another 0.1 there. They're the coupling capacitors to the output tubes. So let's just zoom across a bit further, just have a look in this end of the amp. You can see, it's had quite a bit of work done to it. And it's been done well, most of it, from what I can see. I don't see, the only problem I do see is these have got rivets again. They've been used as grounds, and it's a no-no. You can't see that probably with a macro lens on, but that's a no-no, I'm afraid, as we've seen on previous videos. Like I said, that they're solid enough. It's just if they have a tendency to come loose. In fact, I'm not sure though, they've got a star washer on there. I mean, just get some stronger glasses, but I think that there's star washers on those. So they've certainly made every effort to keep those from coming loose. So this tube socket is riveted onto the chassis, and then they've just soldered onto a lug that's on that tube socket there for the ground, and that's not good enough, so we are going to have to change that. Probably get that into this hole here if it will reach. Other than that, I don't see much else. Alternate connection there. Remember, these transformers have two connections, and not sure which one they'll be on. I tend to go for the one with the slightly less plate voltage on there, but because you tend to find that it gets a bit over biased if not. Looks like 125 ohms for the cathode resistor there. Don't see a cathode bypass cap. Well, I suppose we better get it fired up and see what it's doing. So we're just looking inside here. We've got some Coke bottle 6 L6s. Let's just have one of those out. Have a look at that. Made in the USA. National Union Electron tubes, sorry. If they're the original ones, I bet they are. Yeah. 5V4G for the rectifier, and that tube socket is incredibly loose. So look what that is. That's actually not, oh, it is labelled there. and it is a 5V4. I think there you can just about make that out, but that socket is really loose. My days. Yes, I think we may have to be changing him. Just move the camera a bit more. Look. Yes, and these two aren't great. That one's bad, that one's not too bad, but that one's not great, and that's terrible. And then we've got a 6 SL7 there, so that's good. And then I think these are 6SJ7s, 6SC7, 6SJ7. We've got the hum adjust control. And something here which is coiled up. I'm not sure what that's all about, but whether it's something to cancel noise or what it is. Right, so we've got it up and running, and you can see they've got 264 volts going on, but it is on the current limiter because this amp has been through the post. So I've got a bit of a hum when the volumes are turned down, but no AC hum from this switch, this on-off switch, which is on the phono plug. So we've only got 16 microfarad here on node 1. So take it off the current limiter. All sorts of strange things going on while you're turning the controls. 309 volts we've got on there, look, on the plate. That's what's hitting the plate. So not a lot of voltage on this one, but that's okay. But that noise is quite three-pulsious. So right, I'm just gonna parallel the capacitor in and see if we can get rid of that noise. And there we go. And I'll just use this to discharge it. There we go. Now that was a 47 that I just tacked on, and that's a bit too much for this amp. 32 is about the maximum we can have with that rectifier tube in there, probably. I have to measure the winding to be sure on that, but I'm pretty much certain that's what that would be, 32 microfarad. So we may change that to a 32 and put an F&T in there. In fact, I'm not too sure. If we look here, that's a 22. So let's parallel that one in and see what that does. Now that one's not done as much. Is that? That's not quite grounded on there, that's why. Yeah, and you can see that's made that loads quieter. So that needs to be changed. Let's discharge that again. There we go. So we can upgrade that. Now then, let's have a look at the screens as well. what we've got there. So it looks like we've got 16 on the screen as well there, I'm guessing. Yes, that's on the screen. It's been 4 there. So I think we could upgrade that as well. We've got no screen resistors on either. Right, so I've got a meter here. And I'm just going to test some voltages. Just take the current limiter off. So we know we've got 318 on the plates. Let's have a look at the screens. 316, 239 on the. So where's that being dropped? $119, 255. Ah, this is a resistor. Of course it is, it's valued on there. Haha, there's its value, look. I was thinking straight there. I've just realised what that is. What is that, 2.5k? That seems about right with that drop. 2.5k? I think it is. Let's switch off and measure it, see if I'm correct. 20k. Let's see. 2.5k. 2.57. Yes, indeed. So that's very good. We've got that. So we've got. That's excellent. Switch it back on. Let's just test further down the line, see what we've got. Go back into volts. So what we got here, 10k, 212 from 242, 240, and we've got 207, and we've got another one here going down to 156, and we've got these 55. My word. Right, let's see if these Sangamos are leaking, shall we? So if we just hone in a bit there, these. Right, let's have a look. Is that to ground? So this must be a pentode tube. So we've got 56 volts coming off that plate there. That 100k is feeding it there, you can see just about. And then we look on here, well, there's nothing on there at all. Nothing. Let's just go down the range and have a look. No, that's not leaking at all. That has surprised me. And then we've got, is that going to pin foot? It is. That's going to ground on this. Just take that up. 40 volts. That's on the screen, and that's the screen capacitor to ground. Nothing on there either. And we've got one here. We've got nothing on there. 48 on there. Let's bring that down to 2 volts. No, nothing on there either. So these caps aren't leaking at all. So I can see why these have been left in here. There's nothing on that one. 52 volts on that one. Although I'm not sure about the way that's been put in there. It's a bit close to the ground on there. Let's see again. 2 volts, nothing really. So they're not leaking at all, those 4 Sangamos. Surprising, but they're not leaking, so I don't see any point in changing them. I mean, I could change them just for reliability's sake, but I think in this instance I may not change those. See what the customer says, but they work okay. Right, so we've had a bit of a look there. Let's just see what we've got on the bias. We've got 20 volts. Let's just see what... Got 11 volts going across that resistor there, and we've got 314 plate volts. So we need to take that 11 volts off the 314, which is 303. Resistor looks like 125 ohms to me. We'll just do a rough calculation and see what ballpark the bias is in. Right, so we've got 11 volts, divide by 125, divide by 2, take away 5% for the screens, times that by 303. So those tubes are only running at 12.6 watts. Really low. They should be 19, so they are quite the bias on this is quite low, and I can tell you that one of the reasons for that is the low screen voltage with this in here has dropped the screen voltage. Dropping the screen voltage has dropped the bias on the tubes. So yes, we're definitely lacking a bit of gumption there. That's probably a bit too low. There's some strange things happening with those controls, probably due to the lack of filtering that we've got on there. Right, we'll switch off. So the other thing now we need to look at is how we're going to mod this, because the first thing that becomes obvious to me with this amp is it's only got one input, and that's on the front, which is going into the 6J7 by the look of it. And we need to split those channels, so it looks very much to me like they've wired the guitar, this socket, so the guitar goes into channels 1 and 2, and you can control it from either. That's what I'm guessing's happened there. And someone has removed, because on this side here we've got phono mic 1 and mic 2, so not a lot of versatility with this amp. So that's something to look at. Right, so we've got the guitar plugged into it. I'm not sure. Strange things going on there. So it looks like the guitar's going into all 3 channels. There's the phono. Turn that down. There's mic 2 and mic 1. Not sure what the point of that would be. So that's the phono channel, flat out. And that's mic 2 on about number 2. So not really sure of the use of that phono channel. All these two channels, mic 1 and 2, just seem exactly the same. And they've just been wired together. Just have to check the circuit and see exactly what's going on with that, but I think we can do better than that, can't we? We could do is splitting these channels and having something different on each one rather than them just being the same. They're also interacting with one another. So if we look, we just go one of the knobs has come loose on there, so just got that off for a minute. Look, you can see how that's got that one's okay, just those two. So just have a bit, they've got a bit of a very strange. So there we go. It sounds okay. It don't sound too bad. So let's just have another look. So one of the problems is the bias, and I can tell when I'm playing through it, the bias is really cold on this. The tubes are only biased at 12 watts and they should be biased at 19 or a little bit under that would be fine, but 12 watts is a bit too much. I've got to sort that ground out and do that properly because that's not good enough. Now there's some options here for the customer really with the way this is. So at the moment we've got this 5V4 in. If I put a solid state rectifier in this amp, and we've got one here that we use, well not that one, but it's built into one of these, it's kicking around somewhere. If we put the solid state rectifier in, that will increase the plate voltage and it will also increase the bias. There's quite a big difference between the screen voltage and the plate voltage. There's no screen resistors on these 6L6s, so we're going to need to put some screen resistors on, which will drop the bias slightly more, not much I wouldn't have thought, but it will when the amp's cranked. Screen resistors drop more voltage when the amp's cranked up than when it's sat idle. So we need to rework some of this power circuit. If the customer had a solid state rectifier in this and used it all the time, we could up the microfarads more on the first cap there. That's 16, which is just too low for this amp, and we can tell it is noisy. But we need to rework this power supply in some shape or form. We have got maximum we can have on there with the rectifier tube is 32 microfarad, which will be fine. The screen is also 16 microfarad, the screen smoothing, so we could put that up to 32 as well. But if you use a solid state rectifier, we could put 47s in for both of those, which then it would be really quiet and would thicken up the bottom end, make it firmer. So these Sangamo caps, should I leave them in? Should we change them? They're working absolutely fine. They're not leaking one iota. But you guys in the States know more about those caps than I do. We don't see those in amps in the UK. So let me know in the comments what you think I should do with those. Definitely need to sort this power supply. This resistor here, this cable resistor's got to go. It's dropping way too much plate voltage, screen voltage, and that's what's keeping the bias low. And yes, I could swap the resistor and whatever, but that's already mounted, and then I'd have to be trying to mount that somewhere and whatnot. And I'd rather just, to be fair, I'd rather just change the power supply, because I've got to change these caps anyway. We need an HT fuse in it as well, so that's another reason for reworking the power supply. There's no HT fuse in, and it must have one. Can't not have an HT fuse, so we need to sort that out as well in there. And then we need to do something with these channels. They certainly need, the phono needs doing away with. It's useless and pointless, the phono channel. It's got no gain whatsoever. It's just pointless. So we turned the phono into a master volume. That's what we did on the others. If we look on here, we've got the phono here. If we turn the phone so we'll mount the sockets on here for the two channels, which is where they were originally. Just put a blanking grommet in the phono there, where the phono input was. And that's the best way of doing those channels. We need some grid stoppers on the output tubes as well. I think that's about it really. So the ground, HT fuse, rework the power supply, split those channels, make a master volume out of the phono, put the inputs on the side again. So that'll do it for this one. So thanks for watching. You all take care, and I'll see you all in the next one. Bye bye for now.